better health outcomes for people. So with that, I'd like to turn it over to Thavarajah.
Thank you, Jack. That should be way to the end. Okay. How many of you know that 2016 is the year of pulses? One hand. And there's 5 different types of pulses here. Hands up. How many of you tried all 5? 1. Did you? 2, 3, 4. So I was expecting half of the hands up. So we're going to talk about pulses. This is something, lack of information, especially for south and east of United States. I know people in California, they eat a lot of chickpea and they grow a lot of chickpeas. So this is something I'm planning to encourage you to eat. Should I close the door or leave it? I can do that. Okay. So to start, I like to give you a little bit about my journey. This is the world map. This little teeny tiny country called Sri Lanka, that's where I am from. It is really, really small from north to south. If there is a proper highway, we can go in 2 hours from top to bottom, 2 hours. But there's no highway. So it takes a week. No, not week, 2 days. And then this is a smallhold farmer, and he's a happy farmer. He grows rice. That's our major crop. Okay? And then my journey, I went to Saskatchewan. Anyone you know Saskatchewan? I know one of the Canadians sitting in the front. Do you know Saskatchewan? So if you're a Canadian, you need to know how to spell Saskatchewan. That's a test before you get the Canadian passport. That's what they did. So that's Saskatchewan. Totally different from Sri Lanka, where it's very tropical, moving to tundra. Okay? And this is a very common picture. Very big combine driving through 1,000 hectares of land of living sky. That's what the Saskatchewan is called. So when you compare, you know, I grew up in Sri Lanka eating mostly rice with pulse crops. And then I didn't know that time pulses actually grown in Saskatchewan. I was thinking, as a little person, I thought pulses coming from Mysore. It's a small part of India. But that's not true. All these pulses came from Canada and Australia, which I happened to know when I was a graduate student. All right? So here is the comparison. Look at it. Sri Lanka has 20 million people living in that tiny world. And it is like 10 times smaller than Saskatchewan. And you see the 1 million people live in Saskatchewan and 20 million people live in Sri Lanka. And look at the weather. And what is the difference here? The cropping system and the wealth as well. Sri Lanka is a developing country. Canada is a very rich country. So our major crops are rice and tea. And then I moved into the world's biggest and the world's best bread basket coming from Saskatchewan. If you ever eat bread coming out from Saskatchewan wheat, actually it tastes really, really good. And pulses and the oil crops. So this is the difference. So my journey from small food system to the large food system. And then that's what interests me to work on, because the country I come from, 30% of the population is malnourished or iron deficient. Okay? When it's come to Saskatchewan, less than 5% is iron deficient, other than the First Nation people. So therefore, it's a difference. That makes me interested to study food systems as a graduate student. So that's what I want to tell you. This picture is from FAO. Everybody knows what is FAO, Food and Agriculture Organization. And this is why small farmers are important. Even compared to Saskatchewan to South Carolina, I haven't talked to you much about it. Before that, I was in North Dakota. South Carolina has a considerably small farms compared to even North Dakota or to Saskatchewan. But I wanted to give you an idea what is a smallholder and what is the large scale producer. And if you take my class in the fall, I teach the differences between these agronomic systems. So 95% of the poor people actually live in this side of the Asia. But India is getting much better now. They're very well populated, but getting much better, because this is a picture from 2016. However, it is shame that 900 million people living in extreme poverty when we use our cell phones and all this life that we have, but people in Africa and parts of Asia, about 900 million people in Hungary and the poverty. So that's why we need to focus on the food system and how we can bring people to how we can bring the food to these hungry people. Are we going to produce good food, or are we just going to produce starch? So the question for you guys. Anyone heard about the global hunger index? So I said there's a disparity between the developing countries and the developed countries. But how do we tell this to the world? There is an organization in Washington, D.C., which is called International Food Policy Research Institute. What they do every year, they have ground staff, they talk to these countries, and then they combine and make an index called Global Hunger Index. If people who are interested, this is online document, okay? And what they do, this ground staff, they go measure 4 indicators: undernourishment, child wasting, stunting, and the mortality. For each country, they take these 4 measurements, and then it's just like a test. I give you a test, someone get 100%, someone get 35%, and then I standardize it. And then you make an indicator. That's how we know how many people in the world are hungry. So, hunger, this is the FAO definition. Hunger is referred to the distress associated with the lack of food. That means less than 1800 calories a day. Now the question, I don't actually eat 1800 calories a day because I'm full. Is this 1800 calories going to be empty, or are those going to be healthy calories? That's the question. So are we going to feed these hungry people with starch, or are we going to feed them with the nutritious, rich food? Okay? So that's the definition. And this is how they calculate it. I teach this in my class very in depth. So the step 1 and step 2, step 3, what they do, how much people don't have food, including the adults and the children under 5 years old. And then the wasting is how much height to the weight. And then the stunting to the age, how much height, and then the mortality. So common ground, and then 4 measurements, and then they standardize it. And then here how there's a computer model for that, and then they calculate the final number. Okay, let's look at the numbers. Here is the numbers look like. The world, actually we have been good. We have been doing quite a bit of work. You can hear?
No, I just have a question about the last one.
Oh.
You said the wasting was age to weight or age to height?
Children under age of 5 without height is low from the, I can't read it.
He's asking about child wasting.
It says children under 5 whose weight is low for their height.
Is stunting?
Yes, that is stunting. Wasting is the weight. Are you asking for wasting also?
No, you said wasting was height versus weight.
Here is the wasting, sorry. Waste is the weight. Think about it. The wasting, weight. You don't have enough weight for the height and the age. That both matters.
Stunting is age versus
height. Okay? So, look at the numbers. The world. So, this is 2015 data. I do not have 2016 data yet. Okay? It will be available in November, I think. So, look at it. From 1990 to 2015, actually, global hunger index is reduced by about 20%. 35.4 to 21.7, which is good. So we have been doing something to do this, right? The world is very good. So, but I wanted you guys to focus on Sub-Saharan Africa, Asia. We are doing something good because if you look at the 1990s, it's like about almost 50% global hunger index, and it's reduced almost to half. So that means people have been working very well. So I'm going to talk about those stories to you, like what people have been doing, especially related to the pulses, okay? Global child malnutrition data. This is from World Bank from 2015. This will answer your question from the back. Stunting. Okay? The global trend in stunting actually going down. That's why we are happy. Because I'm going to tell you the story what happened here. We worked together and we developed crops that are enriching these nutrients, and these kids and the children under 5 years old, they have this nutritious food. That is why the reason this declining trend. Okay? This is very recent data. And look at the wasting. But still, we have 7.5%. It used to be, when I was a graduate student, it was about 20%, I remember. So now 7.5%, which is very, very good. So that means we all together doing something. So that's why we need to educate all of you what's going around the world. Wasting prevalence, this is also very recent data, 2014 data. And Africa is actually not bad. Now it's like poor. I mean, it starts to growing up and people getting enough food, not enough, but we are doing okay. India is still orange. That means they have a lot of population problems as well as they have a sanitary problem. And any one of you travel to India. If you travel to India, you will see that. When you walk on the streets, some places are beautiful, they're rich, but when you go to the real ground to work with the farmer, where I usually go, it's very difficult. Sanitary conditions are really bad. The family might not have a washroom or the toilet, so think about it, okay? And Africa, on the other hand, the population is less, and they are clean. So if you go to Ethiopia, it's actually really, really clean. Water is not safe. It doesn't mean that the country is not clean. Country is really, really clean. When you go to Ghana, they are quite a bit rich. But if you go outside the Accra, you will see a lot of plastic, polythene. That's how they get polluted their country. But other than that, compared to India, Africa is much safer. I like Africa because you will get sick because of the water problem, but other than that, you're okay. So, yes.
You might end up getting to this, but on the last slide, so Oceania, like, how do you help out communities like that, like islands that are on atolls and all that can't farm and everything?
Yeah, that's true. I have a group in Australia. I work with Western Australian University, and they actually write a grant, and they got some money from even USAID, USAID, and they are developing these gardens like Alex is doing in Tiger Garden model, like a small garden, and they just grow up enough amount of vegetables just for their small families. So yes, it's a problem, and we don't even think about it because, like, I'm a researcher. I focus on Asia and Africa, and those it's
very different.
Very different. And I never even been to that side. I only been to Africa and India. My experience. So now I want you guys to think about why this disparity between the developing countries and the developed countries. Why there still hunger exists. So me and my colleagues, we put together this book chapter. This is a book chapter for the grain and legumes because this is the International Year of Pulses. We looked at how is the food supply. Look at the fat supply, grams per capita per day, per single person. Look how it is going to be rising, okay? And then look at the sugar, because America is having a problem. We have a problem of obesity, right? Why? Because we eat most of our food has added sugar. So look at the sugar consumption. And then I'm only going to focus on pulses and look at the pulse consumption. Can you see the gap in between the sugar and the fat and the pulses? So this tells you why it is malnutrition happening, why it is obesity happening. Yes?
Sorry, this is going to be a very vague question, but can you explain what a pulse is?
Oh.
Is it a certain type of legume? Or?
Well, the first picture I show you 5 different kinds. Okay, pulses are legumes. Here is the definition. Pulses are known as like 4-H crops, or it's like you eat your oatmeal. So it's like that's the word pulse came as from it's written in even the Bible. So all the pulses are legumes, but all the legumes are not pulses.
Okay.
So pulses are the crops which has more than 20% of protein.
Okay.
And less than 1% of fat. So when I say pulses, it is lentils, peas, chickpeas, fava beans. Have you heard about that word, fava bean? Mm-hmm. Okay, fava bean is like whiskey. Some people like it, some people don't like it. Because some people don't like scotch, right? The exact same thing with fava bean. I hate it because it's bitter. But when you go to Africa, they love it. So those are the pulses.
Thank you.
Okay?
Thank you.
And the common beans. Here in South Carolina, you eat the butter beans. That also a pulse. Okay? All right. So now we know the production of fat, sugar, and the pulses. We see that there is a difference. So now let's see where the calorie come from for the developing countries. Can everybody see this picture? Okay. I want you guys to see the pulse bars. It's getting smaller and smaller. And then people getting bigger and bigger, or get malnutrition get increased. And then look at the sugar bar. It's getting bigger and bigger and bigger. Everything we eat has the added sugar. And all together with the cereals, also higher. So still we are producing a lot of cereals. Yes, we need cereals because that's our energy provider. It doesn't mean that we can forget about the protein-rich crops. Okay? That's why pulses are so important. Protein and micronutrients. And this is the per capita food consumption in India, 1950 to 2010. Think about it a little bit. If you eat cereal and millets, what do you get? Energy and protein. If you eat vegetables, lots of vegetables. But the problem in India, because of hygiene, they had to cook for a long, long time to kill the bacteria. So when they eat vegetables, because you can't have a raw salad there because of the water, you'll get diarrhea. So therefore, there's a cooking problem there. So then most of the nutrients can be gone if you cook for a long, long time. And then look at the pulses. Doesn't matter. You can cook whatever you want. Here you go. It's very balanced. It has energy, protein, vitamin, mineral, fats, essential fats, and the fiber, dietary fiber. So that's why we promote pulses. We want cereals to provide us the energy, and we want pulses to provide us the micronutrients and the proteins. All right. And then this paper came 2016, April 2nd. I teach a graduate course for food systems, and I give graduate students to evaluate this a paper because it's really, really interesting. This data is from 15 years, that the epidemiology data that they gathered, and they wrote this paper. What the conclusion was, the world has transitioned from an era underweight or the malnutrition prevalence to obesity. So malnutrition is not a problem anymore. What is the problem? The obesity. So, does this make sense? What you eat in private, you wear in public. That makes sense, isn't it? That's what I'm saying. So everything is changing. We talk about hunger, we talk about micronutrient malnutrition, but now we need to more focus on this. If we don't do that, our society is going to be suffered from all the non-communicable diseases like diabetes, cardiovascular diseases, cancer, so many other things, okay? High cholesterol, high blood pressure, all of these things. So what you eat in private, you wear in public. So that is a very good statement. And proving that, look at this. This is the body mass index, which is not a great indicator, but this is what they used. This is for the female. Look at the Middle East, parts of Africa, and America, it's like dark, really dark. And India is okay, but that's not going to be steady like that because they are transitioning from their economy from low income to the middle income, and then do you know where they go? They go to McDonald's. In Delhi, there's like several McDonald's, and instead of they eating their lentils, they'll go eat McDonald's. So this is going to be read pretty soon. So we got to talk about this, and we got to promote the good food. And here is the male, same pattern, more dark, I think, more red. So having all these problems, WHO, World Health Organization, set the targets for 2025. So they had this meeting and they set the targets for 2025, 40% reduction in stunting. So we need to develop more foods with zinc, okay? 50% reduction in anemia. That means we need to develop more food with iron, bioavailability. 30% reduction in low birth weight. That's what Bill Gates is working on. He's pouring money to Bangladesh and Africa to reduce the child mortality. Okay? No increase in overweight. I don't know how we're going to do that. 50% increase in breastfeeding to reduce the child mortality and maintain wasting less than 5%. Right now it's 7.5. We are doing all right. They wanted to reduce it by 5%. I think we can achieve these goals if we can link our food system into the human health. So the outcome of our food system is healthy people. Remember, it's not the yield. When you have your vegetable garden or when you have your rice farm, yield is not the... But I can say that because yield is the driving force for the farmer, right? Because otherwise farmer will not grow. Money speaks, right? But as a community of educators, we need to talk about how we can link the yield into the nutrition side. Okay? That's a challenge. To do that, this is the model we use. This model was developed by Dr. Combs, Dr. Welch, and then another professor from Australia. And they get together, and this is the model that they used in 1980s. This is the model they used for the biofortification. This is the model I am using now 20 years later. For most of my research, I used this for Africa and India, and it worked perfect. And look at the core. Look at the core of the food system. Production. You need to produce the good food, and you need to make sure that you need to have acquisition. And then the utilization. That's where the food science department comes. They will make very nutritious recipes and extension component and how you're going to eat. So our agronomy people, they're going to produce the crop, and then we need to make sure farmers can access that, and then the food science and nutrition people need to make it better. So look at each component. Genetic improvement, that's where we coming in. Crop diversification, agronomic practices. See, every component is so important. So don't think that nobody is important. Even the animal science is important. We need milk to the farm family. Not only that, policies, the government had to involve with that. That's why the policy is so important. Policy, public health. So that's the outer layer. Protect the food system. This is our food system, and it will be protected by the environment and the socio-economic factors. So graduate students usually develop their own food system for each country. So this is the model. Remember to use all these components. So when you look at it very closely, this is how it actually looks like. Here is the food, and this is all this agriculture food and animal and all these people, environment, climate change, everything, okay? And then whatever we made that food, it had to be nutritious, and that's how we get the food security. Food security comes with the nutrition security. Everybody clear with that? Every single person working in the food system is so important. It's not only the breeder, it's not only the agronomist, it's not only the soil scientist. We all need to work as a united community. Food science, nutrition, breeders, agronomy, soil science, you name it, chemist, we need a chemist. You name it, anybody. And the policymaker and the government, senators, presidents, we need all of them to build this system, get going. Questions? Yeah.
I've had a lot of thoughts while you were talking, but one of the things I was thinking of, I wonder, are there racial and gender differences, say, for packing on pounds given the same food? Because Indian food, my favorite ethnic cuisine, makes me fat, but it doesn't appear to make Indians fat. Of course, they have nothing but the curries and the tikka masalas and whatnot.
Well, can we?
I'm wondering, in other words, if there's a standard issue food platter that can be given to every culture in every nation on Earth, and we would expect the same results in their body index, for example.
Because your body speaks for you. Because from your head to toe, you have billions of microorganisms that decide who you are. So that's why you can't eat Indian food and Indians can eat it and I can eat it. That's because your biome is different from my biome. So that's why we need to understand about this food, and we need to understand about this different socio-economic background, and then work with our gut microbiome. That's what we do in our lab, because everybody sitting in this room has a different gut microbiome that decide what you eat, when do you going to get the headache from this food or your
More
food.
than anything else.
More than anything else. Microbiome drives who you are, where you are, and it's just, can you believe it? Like just tiny people in your body. Telling you to get a headache. Like,
well, how much is microbiome and how much is genetics? I mean, do you have that would determine your response to different diets?
that can play a role too, but microbiome is like, so there's a group in Duke, in North Carolina. They actually found out what my appetite, like I want to eat a McDonald's today, that is more by not the genetics, it's more the what in my gut. So, but genetics play another role, but how much this food can be absorbed into the body, like how much cholesterol can be produced. Even though you eat so healthy that feed your microbiome, still you have like 50% of genetics. There's a really good book from Deepak Chopra, and he wrote this book called Super Genes, and he said, yes, genes play 50%, but you can change those genes by eating really well. That's called epigenetics. So genetics has a component. Like for me, my family has all these bad diseases. So even though how much I eat well, my old age, I'll have all these diseases. So, but I can push that to end of my lifespan by having a healthy lifestyle. I don't know whether I answered your question. Okay. So the failing food system can be fixed by, these are the approaches we use: breeding crops that have higher nutrient content, that's the biofortification; increasing diversity of food crops. So small farmers have 1 acre or less than that. So they grow vegetables, legumes, and also they have a rice patch. So They can sell excess and they can cook a good meal. They can have roots, some starchy food, some micronutrient-rich food. So diversification is a part of the extension job. So breeders, we talk to the extension people. They need to educate the farmers. All right? Reducing the losses of nutrients that occur with post-harvesting. That's the food science. So there's a lot of food scientists, they are working on the post-harvest activities, how you can preserve that nutrients. This is very much a problem with the vegetables. Because if you produce a huge amount of leafy greens, what are you going to do with that if you don't have a cold storage? So those are problems. And also, change the mix of food. And this is the My Plate activities. You need to have a different color. If your plate look like a rainbow, that's awesome. Okay? And because it governs the absorbance and the bioavailability of nutrients, nutrient concentration in foods doesn't matter anymore because it's governed by the microbiome in the gut and how much food matrix, other components in the food, going to govern it. So concentration, I'm not interested. I'm interested on bioavailability. That means how much I eat going to be absorbed into my body. Make sense? Okay. Anyone know who is this guy? Yes. So this is the silent peacemaker, went around Africa, and he bred, what did he breed?
Rice.
Rice or what? Wheat. He's the father of the Green Revolution. He walked around Africa and he produced all these dwarf varieties with very high yield energy because people are hungry, really, really hungry. This is the man gave us the food that time. That's a long time ago. But he was thinking about producing a lot of starch food and then it gives more money to the smallholder farmers. They forget about small crops like vegetables and legumes. Because if I have a 1 acre land, I wanted to grow all rice and get money. I don't care about pulses. I don't care. I care about money. So he's the one produced all these new hybrid and all high yielding wheat varieties. So he won the Nobel Prize. Okay, that's the Green Revolution. So now, in 1970s to 1980s, after the Green Revolution, the half of the population in the world were suffer from anemia and micronutrient malnutrition. So these people, Combs, Welch, Duxbury, these people from Cornell University, they got together and they thought about, okay, now we had the Green Revolution with wheat. How do we add another 2 letters? How do we make it greener? That means having starch. And also, how do we incorporate the other nutrients like protein and micronutrients to reduce the micronutrient malnutrition? So what they come up with, they had a huge big grant from USAID and the Bill and Melinda Gates Foundation. What they did was they started breeding crops with high micronutrients, that iron, zinc, provitamin A, and folates. That's what they were thinking. They thought, okay, let's get a breeder and let's see what's in the soil, how much plants can take up. Can we genetically, not engineered, conventionally breed to increase the iron, zinc, selenium, protein, any of these micronutrients? So these are the crops that they have been working, but we started this when I graduated in 2005, I started the Selenium program looking at, is there a way that I can increase the selenium concentration in lentils? So we start with lentils. That's the Canadian program. Now they release more than 10 lentil varieties rich in selenium. So it takes 10 years to get the lines out from the breeding pipeline. It's not a small thing like you can get it in a week, like in 1 year. It takes 10 years to release a variety. So now in Canada, they release quite a bit of high selenium lines. They have high iron lines, zinc, and same thing with America too. Okay? So what is biofortification? Biofortification is like you pick the right parents and then you breed them and then you get the babies with the high nutrients. That's the simple version. But the finding these parents are so hard. My lab does is mostly screening. Screening is like we have these populations of wild types, wild generations, or it was grown in somewhere in the world, and it comes to our lab, and we measure what is the nutrition quality. And then we tell them that, okay, this parent A has high concentration, and then I give that to the breeder, and then breeders start crossing. So it's like making babies, like we pick the parents, we cross them, and then we make a population, and then we release the variety. So this process will take 5 to 10 years. So the biofortification program started in 1980s, and now we can see the varieties are releasing. So I worked with the Harvest Plus for pearl millet. Every pearl millet variety that they released to India, I certified them, and then I worked with them for the beans. And actually, if you like to listen to the corn story, Dr. Mike Go is coming from Cornell University, and he's giving a talk on October 10th. So he will talk about biofortified vegetables and corn. So the international partners are the Harvest Plus, and this is their 2016 article, like their report. And they told that they have produced all these varieties for beans, finger millet, cassava, and also rice, high iron rice, high zinc rice, and the cassava with the provitamin A. Okay? So because of that, this man, who was the founder of the Harvest Plus, Jerry Combs, Ross Welch, Duxbury, and Howdy Boyce. Howdy is economist. I know him very well. And Howdy went to the Gates Foundation, and he got the money, and then he started the Harvest Plus because everybody else is a Cornell professor. So they helped Howdy to build this. And this year, who won the food prize? He did, because he actually did a wonderful job. It's like Balog's story, green revolution to the greener revolution. Can you see the connection here? So he won this year food prize. And then what they do, these guys in Washington, D.C., in America, and these guys have all the money, and they give this money to the different centers. The center I work in Morocco, it's called International Dryland Agriculture Research Center in Morocco. They breed lentils for high iron and zinc and provitamin A. So this is actually one of the varieties that we work and which is released in India. And this child, because I was in Morocco this April, because this is the International Year of the Pulses, and we were talking about nutrition, and they show me this picture. This is something that we analyze in our lab. And so we are proud of that. And this is the faba bean. Remember I talked to you about Scotch? This is Scotch. So this is how these farmers are very, like they're small communities. It's quite different than high-tech, what you guys have. So this is how we select the food system crops, what crops that we're going to establish. We discover the crops, like I said, the parents, and then we test them in the field, and then we release it to the farmers. At the end, 2 years later, we will go back and see whether that trait, the quality trait, iron or zinc or selenium or whatever that trait, is still there. Because it's a genetic trait, it can be gone because of the environment. So every year we check that. So we'll see how long this will last. And this is the list of varieties, target crops, and the traits, and the countries were released. And here is the release schedule. So I worked with the lentils one, and these were almost all released. And I just talked to the breeder, and he said that 20% land production increased in most of these countries, especially Bangladesh and Ethiopia. Bangladesh, we released a high selenium lentil variety because of the arsenic poisoning. And it's very successful stories. and farmers are happy, they get more price, and also they get more yield. That's where our research is going to help them. All right? And I want to show this. This is the crop calendar. Now it is online, so anybody from that country who is going to work on what crop, and they know when to plant, when to harvest. So pulses. Pulses, I talk about lentils, pea, chickpea, and all these are from North Dakota that we made this food. I don't have a food lab here, but we will eventually. And my students make this. And this is pasta enriched there, like, you know, instead of cheese, we put lentils in there. It's really good. So why this is good? It provides 25 grams of protein, less than 1 gram of fat, and no cholesterol. Most importantly, 20 grams of prebiotics. That's the food for your gut microbiome. So when you go home today, at least eat some lentils or beans or some sort of pulse crops.
Or black beans.
Oh, black beans. That's wonderful.
Amen.
Yeah. So like, well, so I told you that I'm not interested in concentration, but I'm interested in iron bioavailability. So when the samples come to my lab, maybe 1,000 samples, we are not going to measure all the concentration. Sometimes it's hard. So what we do, we pick several quality traits. One quality trait that we are working is prebiotic carbohydrates, organic acids, phytates, and carotenoids. Why we do that? If I want to release a high iron or high zinc lentil line, I need to have high prebiotic carbohydrate, because when I eat the lentil, more prebiotic carbohydrate will be released in the gut, and then more iron will be absorbed. So even I have less concentration of iron, it doesn't matter. I have high prebiotic carbohydrate, high organic acid, and high carotenoids. That increase the iron bioavailability. And then watch out for this guy. This is a bad guy. Phytates. Because phytates bind the iron and it make a molecule and then it's excreted out. So we watch out for that bad guys. We can't say 100% bad. It has a good things too. So, but we always look for these 4 properties, okay? And then once we know that, this is how we do. These are my lab results. We get the varieties and we measure all the parameters, and then we make a computer model, and then we pick the parents. So for this breeding program, we actually pick these guys. This one, this one, this one, this one. Because based on the ascorbic acid, low phytates, and the high iron concentration. Mostly, we go for the ascorbic acid. So when you go home, if you want to absorb more iron into your body, when you eat your meat or whatever, drink orange juice or eat an orange, because ascorbate does a great job. But you don't have to. Lentil is a super package which has a ascorbate in the matrix. Nobody knows that. Okay? So, and then we test that with the human studies. I did 2 human studies in Sri Lanka, and we know giving the high ascorbate, low phytate diet, we know the iron bioavailability is high. We feed the lentils to the human, we take the blood samples, and we measure the iron bioavailability. I'm not going to go details, but this is a fancy story. So the farmers, they are using our varieties with high iron and zinc. But the problem with the high iron and zinc, they don't produce enough yield for them to sell it. So then, I have been working for this for almost 10 years, but I could not figure it out. Why? Okay? The question is, will selenium increase lentil yield and seed quality? But it does, but I don't know the scientific reason. So I'm going to get a PhD student to work on that. This is the images we made. This is the nodule. We get a slice of nodule and use the X-ray absorption spectroscopy, and then we map it. That's a lentil seed. That little orange color one is the load of selenium in the embryo. So you grow the plant, and you have it's like an X-ray machine. You can scan it, and then you can locate where is your elements are in it. So this question I have been working for a long time. I have results to show you, but I don't know the mechanism. So there's a PhD student going to start and work on this mechanism. We need to find why, right? So these are the results. Foliar application increased the biomass. Look at that, 5,000 to 7,000. That's a big deal. That's cash, okay? And the seed selenium concentration increased, and not only that, plant protection. These plants were healthier than other plants. That means antioxidant protection is high. But we need to know the genetics behind that. So I'll show you some of the things. This is so interesting. CDC Red Berry is the lentil line originated from high selenium soil, where it's from Canada. And these lines, Aston, all these ILL lines came from Syria. Syria has a very low selenium concentration in their soil. So those lines who genetically came from the low selenium soil, when we add a little tiny bit of selenium, look at the difference of the grain yield. And this is control. This is the high selenium one. And this is the lentil genetics. The plant originated from high selenium soil. They did not respond it. So we are trying to find this is why this is happening, this genetic mechanism. We want to find the genes. So same thing with the foliar application is quite different from soil application because plants are not ready for that. Okay? And here is the antioxidant protection. So selenium does something really good to the plant, but we do not know why. But farmers are happy. But we can recommend them. We need to find the genes and bring them into the genetic pool. So because of the gut microbiome, I thought I should talk about a little bit about it. This is a very hot topic. Everybody likes prebiotics and probiotics, but they don't know what that is. So these are the components in the lentils, act as a prebiotics, and which help to promote the healthy gut microbiome. Okay? You don't need to go detail because if someone taking my food system class, we go detail in the graduate class. So here is the, are we almost done? Okay.
Sorry.
So anyways, this bacteria, it increased the microbiome, and then it's produced the short chain fatty acids, and it increased the nutrient bioavailability. All right, so this is the model. You can see, don't eat the McDonald's today, and that will increase your obesity. This model is the one that my graduate student is using. We look at how many good bacteria are going to increase, and then we model each. We use rats, not humans, and then we see how the bacteria population is going to be changed. Okay. The recommended intakes, if you eat 100 grams, you can have 20 grams, about 20 grams of prebiotic carbohydrate. We use prebiotic carbohydrates as tool to measure the stress, especially raffinose oligosaccharides. That's why you can't eat black beans, because sometimes when you have more raffinose oligosaccharides, it makes you uncomfortable.
I know, I ate a ton of them.
Ah, then you...
I was saying like a lot. Probably like a pound every 2 weeks.
Okay. So I also have a different one for kale, and I'll just show the pictures. I'm not going to talk much about it. If anyone interested, you can read this paper. I'll give it to Jeff. And this one, I need to show you. This is my friend. This is a rooftop garden in Saskatchewan. And this is what Alex is doing. This is the garden before we established the Pendleton Elementary Garden. You can see that there's nothing. It's just nothing in there, right, Alex? And then here you go. Our tigers went there and changed the school forever. And this is what they're going to have. School gardens. So my last slide, what I want to tell you is use agriculture as an instrument for public health. That's all. Sorry about it.
If you have any questions, feel free to stay. I think Dr. Thavarajah can hang around for a few minutes, so please stay if you have any questions.
Yeah.
No. Okay. So will it always be available spraying of next, like? Okay. So I really want to take that supplement of major growth, but I was afraid, like, I also need to take landscape fertility management. But I understand that